This video is about how the conic sections, the parabola, the ellipse, the hyperbola, how those have polar equations which don't look anything like the rectangular equations for the same shapes, and I'm going to take you through what those look like. Here's a very difficult looking equation. 12 over 3 minus 2 sine theta. And if I were to make a theta and r chart and use like the basic 4 angles, when I put 0 in, I'd get 12 over 3, which is 4. When I put 90 in, I get 3 minus 2 in the denominator. 12 over 1 is 12. 180, sine of 180 is 0 also, so that's back to 4. And 270, sine of 270 is negative 1, so it's 12 over 5, which is 2.4. And if I graph those 4 points, it ends up looking like that. And you might suspect that the curve becomes some kind of an ellipse. And it is, it will. Because this equation is, when you see something like that, a number over something plus or minus something times sine or cosine, it's going to be a conic section. Now which one? Well, that's coming. Now earlier in the course we did questions like this. Find the equation of an ellipse with a focus at 0, 0, directrix at y equals negative 6, and eccentricity of 2/3. And to do that, we did that in rectangular. I want to show you what this looks like in polar. So here's the focus. I'm writing y equals negative 6, which is kind of funny because I'm writing it in rectangular form, but we could imagine still y equals negative 6, sort of superimposed on top of the polar graph. And there would be some kind of ellipse. Now to find the equation in polar, I pick a random point on the ellipse and call that point r comma theta. And now I try to find a relationship there. So in order to do that, I'm going to make this line here, and that's r. That's r, if this is r theta, and theta is over there. Now, this blue line has length 6. And if this is an ellipse, the fact is going to be that, oops, sorry, I made a mistake. That line's not 6. Just that piece of the line is 6. Okay, because this is the x-axis, and here's y equals negative 6. Sorry about that. So that's 6. So we want to get a relationship, and the relationship is that the distance to the focus is going to be the eccentricity, which is 2/3, times the distance to the directrix. That's this black line plus the blue line. Well, the black line, we know the blue line is 6. But that black line is, I can see this right triangle here, and the black line is the opposite, so I could say sine theta. I'll say this is r sine theta. Okay, if the hypotenuse is r, the opposite side is r sine theta. So it's going to be r sine theta plus 6. Well, that's it. Except that to make it look a little nicer, 2/3 r sine theta, 2/3 of 6 is 4. Actually, even better than that. Multiply everything through by 3. 3r, and then distribute the 2 through is 2r sine theta plus 12. bring all the r's over to one side. So 3r minus 2r sine theta equals 12. Factor out the r. Need a little room here. Factor out the r. Get r times 3 minus 2 sine theta equals 12. And finally, divide both sides by 3 minus 2 sine theta. And that's why I started with the ellipse and the focus and directrix and eccentricity and ended up with that equation, 12 over 3 minus 2 sine theta, which was actually my starting question. We can go in the other direction. If you told me 12 over 3 minus 2 sine theta, and I wanted to turn it back into rectangular, I could cross multiply. Then r sine theta, that's one of the four relationships. R sine theta could be replaced with y. Or 3r equals 2y plus 12. Now, I have r and y, which is weird to be in the same equation. If I square both sides, I would get 9r squared equals 4y squared plus 48y plus 144. This r squared, one of the four relationships is that r squared can be replaced with x squared plus y squared. I'll distribute it through. And as you can see, this is looking a lot like an ellipse equation. If I combine like terms, 4x squared, 9x squared, plus 5y squared, minus 48y, minus 144 equals 0. Now I could also go in the other direction. If I have 9x squared plus 5y squared minus 48y minus 144 equals 0. The sneaky trick is to add 4y squared to both sides. What does that accomplish? Well, it makes this into 9y squared. What does that accomplish? It allows me to factor out the 9. What does that accomplish? It allows me to get an r squared in there. But I still have this other stuff, minus 48y minus 144. Oh, I see. Why don't I move over, let me move everything over to the other side, the 48y also, and the 144. So on the right side, I have 4y squared plus 48y plus 144. That actually factors to 2y plus 12 squared. Now again, I have this weird equation that's got r's and y's in it, but I can replace y with r sine theta. And now, rather than FOIL it through, I'm actually going to take the square root of both sides and get 3r is equal to 2r sine theta plus 12. And if I subtract the 2r sine theta from both sides, factor out, and then divide both sides, I will end up with, here, why don't I go ahead and do that. So I get 3r minus 2r sine theta equals 12. Factor out the r. 3 minus 2 sine theta equals 12. r equals 12 over 3 minus 2 sine theta. So I'm able to go backwards also. So that was a very specific question with an ellipse. But what if it wasn't an ellipse? What if it was a parabola or a hyperbola? Well, I'm going to show you more generally now. And this will be really general now. Eccentricity, I'm just going to call it E instead of any number like whatever it was before, 2/3 or whatever. And I'll call the directrix y equals negative d. And here's, and my focus is still going to be 0, 0. It's always going to be 0, 0 for these questions. So here's like a piece of the conic. Maybe it's parabola, maybe it's an ellipse, maybe it's a hyperbola. We call the point r theta. This here is r. This here is d. This here, make it blue, because this is theta. So this is r sine theta. And the relationship is that this, r, has to equal E, I'll just keep it called E, times distance to the directrix, which is r sine theta plus d. And when we distribute the E through, ER sine theta plus ED, and bring the r's over to one side, minus ER sine theta equals ED, and factor out the r, 1 minus E sine theta equals ED. And finally, divide both sides and get the general equation, which is ED over 1 minus E sine theta. That is the equation for any conic that has a horizontal directrix that is below the x-axis. And that's an important equation. So I could jump now straight to the answer from before. Remember before, eccentricity is 2/3, focus at 0, 0. I can now jump right to the equation. R equals ED over 1 minus E sine theta equals 2/3 times 6. D is the distance from the focus to direct from the x-axis. D was the position of the directrix. This number. So 2/3 6 times 1 minus 2/3 sine theta. 2/3 times 6 is 4. 4 over 1 minus 2/3 sine theta. And a lot of people don't like to have this denominator here, so they just multiply numerator and denominator by 3 and get 12 over 3 minus 2, minus 2 sine theta. Now the next thing that you can do is go backwards with this process and use it to graph things. So imagine I had this equation, r equals 2 over 1 minus sine theta. So what do we know about this? Well, the 2 is ED, and the E is 1, because this has the form 1 minus E sine theta. So E is 1. So if E is 1 and ED is 2, then D is 2. So that means that our directrix is y equals negative 2. Also, since E is 1, this thing is a parabola. We should expect it to be. We could actually make a little chart now. Now that we know it's going to be a parabola and we know a lot about it, we can go theta r. We can plug in 0 and get 2. And 180, sine of 180 is also 0, so that's 2 again. And if we put in 90, we get undefined, which is okay because parabola doesn't have this point up here. But if I put in 270, I get 1 minus negative 1, so I end up with 1, and 271 is there. And that's why it would look like that. 2 more questions before this lesson's done. R equals 8 over 4 minus 3 sine theta. Okay, it's supposed to be ED over 1 minus E sine theta. This has a 4 here. So what you do is you divide top and bottom by 4. And now we can see that E is 3/4 and ED is equal to 2, so 3/4 times D equals 2, or D equals 8 over 3. So that means I'm down here at like almost negative 3. We also know because of that eccentricity is less than 1. This is an ellipse. So now that I know all that stuff, when I make my little chart, theta r, we get 0, 2, which is here, and we get 180, 2, which is over here. But when we put in 90, we actually get 8. You put 90 into this original equation if you want. Sine of 90 is 1, so 3, 4 minus 3 is 1. And when I put in 270, I end up with 8 over 7, because sine of 270 is negative 1, so 8 over 4 minus negative 1. So 8 over 7, which is a little bigger than 1. And when I connect those, I get an ellipse. There's actually 2 more questions, I think. How about this one? R equals 12 over 2 minus 3 sine theta. I don't want that 2 there, so I divide everything by 2. 1 minus 3 halves sine theta. That's my eccentricity. This is a hyperbola. ED equals 6. That's 3 halves D equals 6. So D equals D ends up equaling 4, which is down here. And we know it's a hyperbola. Now this is a little confusing. When I make my chart, I get 0, 6, which is over here. I get 186, which is over here. When I put 90 in, I get negative 12. Oops. All the way down there. And when I put 270 in, I get 12 over 5, which is over here. So what happens is that this 271 ends up being the vertex of the top branch, and the 91 ends up being the vertex of the bottom branch. So we can answer questions like, what's the equation of the ellipse that is focus 0, 0, eccentricity 3/4, and directrix at y equals negative 5? So D equals 5. We say ED over 1 minus E sine theta 3/4 times 5 is 15 over 4 minus 1 over 1 minus 3/4 sine theta. Multiply everything through by 4 and get 15 over 4 minus 3 sine theta. Okay, I think that's good for this lesson.